This is Dr. Rodriguez going over Chapter 2 for Psych 101 about psychological research. So, why is psychology a science? It's a science, it's a social science because it uses the scientific method to study people. The scientific method is a series of steps that we use to gather evidence. By using the scientific method, we can reduce bias and errors because we're not merely relying on opinion or everyday thinking. There are errors in our common sense, our everyday thinking, our opinions, because they're based on limited experiences. Take, for example, if I was to ask you, do you think teen pregnancy is at an all-time high or an all-time low? You might say, I think it's at a high because I know a bunch of people in high school who got pregnant, and then since then, I know even more who have gotten pregnant or had a couple of kids. And so in your mind, you're like, all right, that must mean, because in my world, I see a whole bunch of teenagers who have been pregnant, that it must be at a high. So based on your limited experience, based on your everyday thinking, you think teen pregnancy is at a high. Now, when you go out and you go get evidence, when you collect data on teen pregnancy, you find out that actually teen pregnancy is at an all-time low compared to, say the 1950s, compared to data that has been collected in the past. It's at a low, and probably having something to do with access to birth control and abortion. So using the scientific method, you get away from your biased or limited thoughts and experiences, and you go out and you observe the world around you, you ask questions, you collect data, analyze that to come up with overall trends or patterns. So if I was to say that teen pregnancy is at a low, that's me talking about the overall trend, what we're seeing. It has decreased over the years. So obviously, there are going to be exceptions. There are still teen pregnancies, right? But compared to the past, it is lower. So with the scientific method, you come up with, you go out and you go get this evidence, you analyze this evidence, this data, to find trends or patterns so that you can say, overall, generally speaking, this is what the data says about the world around us. And that information helps us to be able to make decisions, maybe about policies, about teen pregnancy. If we compare it and we see, oh, wow, it's gone down, that will help us to figure out maybe what we should be targeting to make it decrease even more. So when you're learning about scientific research, always remember that it's the overall, generally speaking, trend. What are you finding? And of course, there are going to be exceptions to the general trend. So don't throw out, whole scientific findings based on one exception. Like if I was to say, do you think that moms or dads abuse their children more? So maybe your everyday thinking, your common sense says, I think it's dads. Maybe you had just watched a movie that showed a drunk dad coming home from the bars and physically abusing their children. So in your head, you have this idea of what abuse is based on some movie or some life experience or something, and you say, I think it's dads. Well, when you go out and you collect evidence, when you collect the data and you look at it, you find that overall, generally speaking, single moms living in poverty with multiple kids are the ones that are more likely to abuse their children or neglect their children. So that offers you some information that you can then use to be able to target the more common source of abuse. So, you prior to collecting the data, you thought it was dads and drinking. So if you didn't know anything more than your limited experiences, you might be like, oh, let's, make drinking illegal, rather than what the research finds is it's moms who are living in poverty who have multiple kids. So maybe we need to be targeting poverty and the stress associated with poverty rather than, dad's drinking. So anyways, science helps us to get away from our everyday thinking, our limited experiences, to find that overall trend so that we can then make better decisions. So what are the steps of the scientific method? Well, first of all, you start off with a question. What am I interested in? What am I interested in? Am I interested in teen pregnancy? Am I interested in child abuse? Am I interested in violent media? So what am I interested in? What's the question that you have? Then you come up with a hypothesis. You try to predict what you would find if you carried out a study. Often a hypothesis is stated as if blank, then this. So maybe if you have access to birth control, then pregnancy decreases. All right, so it's an if-then statement that's predicting what you might find. Then you go out and you design and carry out a study to be able to test this hypothesis. Maybe you do a survey, an observational study, an experiment. And we're going to go over when you would do each of these and the advantages and disadvantages of each of these. All right, so once you have a question, you generate a hypothesis, you design a study, and you collect the data, so all these different numbers, or if it's an observation, maybe you have a lot of notes with words, and you analyze these and you come up with some pattern, you come up with some results that can then tell you if your hypothesis was supported or was it not supported. We don't say that something was proved in science because new data can come along and change that. And the data that you have is really only from a limited sample of people. So we say that the data that I collected in this one study supported my hypothesis. So we don't say proved, we say supported. A hypothesis was supported, okay, or not supported. So once you analyze and interpret the data and figure out if your hypothesis was supported and come up with different conclusions, then you publish that in a peer-reviewed journal. A journal, not like Cosmo, it's a peer-reviewed journal, meaning that peers, professionals in the field, will read over your research and determine if it was done credibly, if it's useful information, if it can be replicated, and if so, then it is published so that others in the field can read about it and then be able to replicate it to see if they will get the same results, or they might do the experiment or the study in a little bit different of a way. So once you publish these results, people can read it and then they can tweak it or add to the field of knowledge already out there. We're sharing the information so that we can continue to add upon and improve upon the research constantly. And once we have all the data and the conclusions and we publish it, people can then modify the theory or confirm the theory or come up with a new question so that they can then do a new study. It's a cycle. Now, when you're designing a study, you're trying to figure out what would be the best way to answer your research question, to test your hypothesis. And really what you want to determine, the question that you have will determine the scientific method, the research method that you use. So say you're interested in describing a behavior. You want to know what is going on. Then you're going to do a certain type of study. If you want to be able to predict behavior, maybe you want to know if something might happen, then you're going to do a different type of correlational study. If you want to explain or figure out the cause of the behavior, then you're going to do an experimental study. So let's go up here and say, look at, if you just want to describe a behavior, if you want to know what is going on, like maybe you're just interested in, is aggressive behavior happening on playgrounds, happening in schools? What is considered aggressive behavior? So if you just want to know what's going on, if you want to describe behavior, you would maybe do a naturalistic or a lab observation. You would write down what you see and what you hear, and you would analyze that for patterns. So a strength of a naturalistic observation. So a naturalistic observation is when you are doing it in a realistic setting. Like if you're interested in aggressive behavior among children, maybe you go to the playground and you watch them playing. Okay. So a strength of naturalistic observation is it provides a realistic picture. So say you're interested in how often people are washing their hands, with COVID having just happened. Maybe you're interested in are people more aware of washing their hands? And so if you were just to ask people in class and say, okay, how many of you washed your hands after using the bathroom? Most of the people in the class are probably going to raise their hand, right? Because they don't want to be judged for not. So That might mean that some people who didn't wash their hands are just raising their hands because they don't want to be judged. It's not really going to give you a realistic picture. What if you instead went into a natural setting where hand washing should be happening, so in a bathroom? So maybe you go into a bathroom and you pretend that you're, using the bathroom or washing your hands or, fixing your hair or whatever else. And you are then observing how many people come in and wash their hands. So you're getting a more realistic picture of what is happening compared to just asking somebody, if they washed their hands. So a strength of naturalistic observation is you get a realistic picture. Now, an observation done in a lab is more controlled, but it might it's not necessarily going to give you a realistic picture of what happens in the real world, but it can still offer some information. So a weakness of naturalistic observation or a lab observation is observer bias, that people act different when they know that they're being watched. So you try to be invisible. You try to be inconspicuous. You try not to let them know that, hi, I'm here looking to see if you're washing your hands. Because if you let them know that, then obviously that's going to influence how they behave, if they wash their hands or not. So you try to not make it well known if you can in a naturalistic setting. In a naturalistic or lab observation, you usually have a small sample because it takes a lot of time and energy to record everything and watch everything that is going on. So because you have a small number of people, you can't necessarily apply what you find to the larger population. You can't assume that what you're seeing in this little group happens in the bigger group. It offers some insight, but you can't necessarily, because a small group can't say that this is what happens in the greater population. And observer bias means observers will see what they want to see. So if they have an idea in their head that guys who, guys at truck stops tend to wash their hands less than, in an office building. Maybe they have this bias in their head, who knows? But maybe then this confirmation bias starts to occur. They start to only really count, or they look for results that confirm what they already believe. So observer bias is when the observer sees what they want to see. Okay. So maybe you want to describe behavior. Maybe you want to know what is going on. Instead of doing a naturalistic or lab observation, you can do a case study. A case study is when you observe one person or maybe a few people that have some, rare disorder or something unique happening to them. And it can provide a lot of information, really rich information. There was this famous case study called with a participant called Jeannie, who she was raised in isolation. Her parents kept her locked away in a room, and she was studied, and they wrote down all sorts of information about her by observing her, because it gave us insight into what kind of effect does isolation have on language and behavior. So a case study can tell you what's going on, but a weakness is that it's a small sample. You're really only studying one person or a few people, and you can't really apply what you find out to the larger population. And you might still also deal with observer bias, like the the observer writing down what they wish to write down, confirmation bias. They might write down even unconsciously write down things that they think is going to happen. And it takes a lot of time and energy to do case studies. You really have to be following one person and writing down every little thing. It takes a long time in comparison to, say, a survey where you have questions and you can send it out to a lot of people. All right, so that we just went over. If you want to describe behavior, you can do a naturalistic or lab observation, or you can do a case study and write down all that you see, and then you analyze that for patterns, and then you publish those different patterns. Okay, the next thing we're going to go over is if you want to do more than describe and you want to predict behavior, what can you do? So that will be the next video.